Today's lesson we're going to talk about finding areas and using something called scale factor. So we already did our warm-up as a group and talked a little bit about what area means. So let's go through a couple of examples. It says use the diagrams below to find the scale factor and then find the area of each figure. First thing we're going to do is find the scale factor, and then we'll find the area of each figure. So if you look at example 1, we have two rectangles. One of them is a scale drawing, and then the other is the actual picture, which is shrunk down, so it's a reduction. It's a reduction of the actual picture. And the first thing they want us to do is find the scale factor. So here's how you do that. You always take your scale drawing measurement and you write it over the top of the actual measure. Scale over actual. And here's what I mean by that. We're going to pick a side of our scale drawing. We can choose. I'm going to pick this bottom edge. It's got a measurement of 8 units. I'm going to put that over the top of the corresponding side on the actual picture. So I have to pick the same side of the actual picture, and that one's 4 units. So we have scale over actual, 8 over 4. 8 over 4 simplifies to be 2. 8 over 4, both are divisible by 4. So you would get 2 over 1 or 2. So this is how you find scale factor. So since it simplified down to 2, our scale factor is 2. Pretty simple. Next thing they want us to do is find the actual area of each of the figures. So let's look at them one at a time. It looks like they want actual picture first. So here's our actual area rectangle. And to find the area of a rectangle, it is length times width. So all we have to do is look and go 4 times 3. 4 times 3 is 12, so the actual area is 12 square units. 12 units squared. We're going to do the same thing for the scale drawing. Find its area. So it has a length of 8 and a width of 6. 8 times 6 is 48. So our scale drawing has an area of 48 square units. And when it's on grid paper, you can actually count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up to 48 square units. But multiplication is going to make that much faster for us. Last thing we need to do is the value of the ratio of the scale drawing area to the actual area. Sounds super confusing. It's really not. We're looking right here. And here's how you do it. You still do scale over actual, but we're talking about area this time. So we're going to write our two areas as a fraction. Our scale drawing area was 48. Our actual area was 12. So you get 48 over 12. And this simplifies down to 4. 48 divided by 12 is 4. That's how you do it. And here's what it means. We doubled the length, or we made the length between the actual picture and the scale drawing is doubled. We have a scale factor of 2. So it was 4 units in one picture and it's 8 units in the other, so that's twice as big. That's where we're getting our scale factor from. But when you double the lengths, it actually makes the area increase by 4 times and not just double. So that's what we're looking at here. If you double the lengths, the area will increase by 4 times. Okay, let's take a look at example number 2. And we're going to keep in mind that when we write these down, we have scale on top and actual on bottom, just like it was in our tables yesterday. So first of all, let's find the scale factor. Pick a side on your picture. Let's do the horizontals or the vertical side this time. On our actual drawing, it's 9 units. On our scale drawing, the corresponding side is 3 units. So we get 3 over 9, which simplifies down to 1 over 3. That's our scale factor, 1/3. Meaning that our scale drawing is 1/3 of the size of the actual picture. Now we're going to calculate actual area. So look to make sure we're looking at our actual picture. And we have 9 times 6. 9 times 6, length times width. And that's going to give us 60. I was going to say 64, not 64. It's going to give us 54. So we have an actual area of 54 square units. If you counted every square unit inside that figure, it would add up to 54. Let's not do that. We're going to find the scale drawing area. So it is 3 by 2. 3 by 2, that's 6 square units. That one we could count. 1, 2, 3, 4, 5, 6. And lastly, we're going to find the comparison of the two areas. So remember, you put the scale area on top. We just found it, 6. You put the actual area on bottom. We just found that as well, 54. And these simplify down both by 6, and you get 1 over 9. So what that means is the area of the scale drawing is 1/9, or 9 times smaller than the actual picture. Another example, in this one we're looking at triangles. Only difference here is triangles have a different area formula. When you're finding area of a triangle, it is 1/2 times base times height. But we'll still do everything else the same. So we'll do scale over actual. We're going to start by finding the scale factor. So pick a side on a triangle. We're going to pick a side on the scale triangle. Here is 8. We're going to pick the same side on the corresponding triangle. It is 6. And we have an improper fraction. 6 goes into 8 once. It would have a remainder of 2/6. Or in other words, that 2/6 would simplify to 1/3. So 1 and 1/3 is our scale factor. Again, meaning that our scale drawing is 1 and 1/3 times as big as the actual picture. And if you look again, if we focus on that vocabulary, this scale drawing is an enlargement. It's a little bit bigger than the actual. All right, let's find the actual area. So we're looking at this triangle here. We have a base of 6. Here's our base number on that triangle. So area equals 1/2 of the base, which is 6, times the height, which is 9. 6 times 9 is 54. And we want half of 54. Or in other words, 54 divided by 2. And that's going to be 27. So our actual area is 27 units squared. And if we counted them, there would be 27. Scale drawing, we're going to do the same thing, same formula. Half of the base times height, so the base is 8, the height is 12. 8 times 12 is 96. And we want half of 96, which is going to be 48 square units. So again, if we counted them, there'd be 48. Last part, we're going to compare the areas. Okay, so we're going to take the scale area, 27, put it over the top of the actual area of 48, and we simplify down. Both are divisible by, whoops, I flipped these. Scale over actual. I had them flipped. It should be 48 over 27. Now we can simplify. Both are divisible by 3. 48 divided by 3 is 16. 27 divided by 3 is 9. It's an improper fraction. 9 goes into 16 once, and 7/9 left over. So this means that the scale drawing is 1 7/9 the area of the actual picture. Okay, we're going to go through these 3 questions together, these last 3, directly under this, and then you guys are going to work on example number 4 and the exercises on the next couple of pages. Excuse me. Okay, so we're looking right here. And it says when the scale factor of the sides was 2, then the value of the ratio of the area was blank. So let's go back up to where we had a scale factor of 2. That's an example 1. And so they said when the scale factor is 2, the value of the area difference was this, 4. So let's go down and plug that in. And all that means is if you double the sides of the length on a rectangle, the area becomes 4 times as great, not just 2 times. Second one, when the scale factor of the sides was 1/3, the value of the ratio of the area was, let's go look. So that's example 2. When the scale factor was 1/3, the value of the ratio of the area was 1/9. When the scale factor of the sides was 4/3, or 1 1/3, the value of the ratio of the area was, and so this is our last one, we can write it as 16/9, or we can write it as 1 7/9 because they're the same number. So let's go with 1 7/9. And it says, based on the observations, what conclusion can you draw about scale factor and area? And this will be really helpful, especially if we rewrite this one as an improper fraction as 16/9. Here's the conclusion we can draw. If you have the scale factor, all you have to do is multiply it by itself to get the ratio of area. Here's what I mean. Look at the first one again. Scale factor is 2. If you multiply it by itself, you get 4. If you look at the second one, scale factor is 1/3. If you multiply it by itself, you get the ratio of the area, 1/9. Last but not least, as we're running out of time on the video, when the scale factor is 4/3, you multiply it by itself, you get 16/9. So that's the conclusion we can draw, that if you multiply the scale factor by itself, you will get the ratio of the area. You guys are going to complete the rest of the packet on your own here for about the next 10 minutes, and then we'll come back together as a group.